So let us pass on to another problem. Okay, write the following function in the simplest form. Okay, this function we have to write in the simplest form. Tan inverse of root of 1 plus x square minus of 1 divided by x. X is not belongs to what? 0. So let us put x is equal to tan theta. Okay, so replace x divided x into what here? Tan theta. So what you will get? 1 plus tan square theta minus of what is that? 1 divided by tan theta. 1 plus tan square theta is nothing but what here? Secant square theta. You already know that. So therefore secant square theta minus of 1 divided by tan theta. So therefore tan inverse of secant theta minus of 1 divided by tan theta. Secant can be written as 1 over cos theta minus of what is that? 1. So therefore on simplifying this thing, what you will get? Tan inverse of 1 minus cos theta divided by sin theta. So I want to know about 1 minus cos theta and also the sin theta. So therefore sin 2 theta is given as is equal to 2 sin theta into cos theta. We already know that. So on simplifying this particular thing, replacing theta with the theta by 2. So what you will get? Sin theta is equal to 2 sin theta by 2 into what is that? Cos theta by 2. This is for sin theta. In the same manner, 1 minus cos theta can be written as 2 sin square theta divided by 2. Just you see this one, cos 2 theta is equal to 1 minus 2 sin square theta. Therefore theta is replaced by the what here? Theta by 2. Therefore on simplifying these things, so what you will get? 1 minus cos theta is equal to 2 sin square theta by 2. So sin theta and 1 minus cos theta, we already got this. Just to substitute for these two things. So what you will get? Okay, so tan inverse is equal to 2 sin square theta by 2 whole divided by 2 sin theta by 2 into cos theta by 2. So here on cancelling these two things, what you will get? Sin theta by 2 into cos theta by 2. So therefore sin by cos is nothing but what? Tan theta by 2. So we already know this thing. Tan inverse of tan theta is always equal to theta. In the same manner, tan inverse of tan theta by 2 is nothing but what here? Theta by 2. So therefore x is nothing but a tan theta and theta is nothing but a what here? Tan inverse of x. So therefore at the last step, tan inverse of root of 1 plus x square minus of 1 divided by x is nothing but theta by 2. Theta is replaced with the what here? Tan inverse of x. We already find out. So therefore 1 by 2 tan inverse of x. So this is the problem we have. So let us pass on to the next problem. Okay. So we have a simple problem here. Okay. So this is sixth problem in your book. Okay. Tan inverse of 1 over root of x square minus 1. We have to write this in a simplest form. So take the same equation here. Put x is equal to what here? The secant theta. Okay. On replacing the secant theta, what we will get? Tan inverse of 1 over root of secant square theta minus of 1. Secant square theta is nothing but 1 plus tan square theta. So therefore just 1 plus tan square theta minus 1. Minus 1 and plus 1 is get cancelled. So tan inverse of 1 over root of tan square theta. Square and the root get cancelled. So what you will get? Tan inverse is 1 over tan theta you will get. What is 1 over tan theta? Is nothing but a cot theta. So therefore tan inverse of cot theta we will get. Okay. So therefore what is cot theta here? Cot theta can be written as what here? Tan 90 minus of theta. Therefore tan inverse can be written as tan theta. So this is the case. Okay. Tan inverse of tan 90 minus theta is equal to what here? 90 minus theta. According to this one, tan inverse of tan theta is nothing but a what here? Theta only. So I had written 90 minus theta. 90 can be written as what here? Pi by 2 minus of theta. So let us consider that x is nothing but a what here? Sin secant theta. So we have here like this. Okay. Therefore secant theta is equal to what here? X. Therefore theta is nothing but a secant inverse of x. So therefore just you take this first equation here, this equation itself, tan inverse of 1 over root of x square minus 1 can be written as 3 pi by 2 minus of theta. Therefore this pi by 2 minus of theta, theta is nothing but a what here? Secant inverse of x. So therefore pi by 2 minus of secant inverse of x. This is the simplest form I can able to write this equation. This one is find the value of this thing, okay, cot into tan inverse of alpha plus cot inverse of what is it, alpha. Okay, so let us consider this one, cot tan inverse of alpha plus cot inverse of what is it, alpha. So we have a tan inverse of x into cot inverse of x. We already know that pi by 2. Let us substitute this entire thing here. So it is the same as this one. Okay, so therefore cot pi by 2. What is the pi value? It is nothing but a what here, 180 degrees. 180 divided by 2. 180 divided by 2 is nothing but a 90 degrees. So therefore cot 90 is nothing but a what here, the 0. So this is the in your book it is a 12th problem. So the next we shall pass on to the last problem here. So here we have, okay, tan. So find the value of each of the expression. So we have to find the values of each and every expression. So we have the one, I have selected the only one problem here. So this is the last problem. It is called the 18th problem. Tan into sine inverse of 3 by 5 plus cot inverse of what is that, 3 by 2. Consider the same equation, tan into sine inverse of 3 by 5 plus cot inverse of 3 by 2. Let us consider sine inverse of 3 by 5 is what here, A. And another part is considered as what here, B. That is cot inverse of 3 by 2 is considered as what here, B. Now let us consider this part only. Okay, that is A into sine inverse of 3 by 5. So therefore this can be written as, what is the cos A? Cos A is considered as what here, root of 1 minus sine square A. Therefore what is A here? A is nothing but 3 by 5. Okay, A is nothing but what here, sine inverse of 3 by 5. Let us put this 3 by 5 here. Okay, 3 by 5 whole square. So therefore what happens, 3 by 5? Cos inverse of this, on simplification you will get a what here, 4 by 5 you will get. In the same manner, let us consider this part here. The B is equal to what here, cot inverse of 3 by 2. So therefore what is the cot B here, 3 by 2. In this case also it is the same thing. What is the sine square A is nothing but a what here, 3 by 5 we have to consider. In the same manner here also. So therefore here the cot B is equal to 3 by 2. So we have tan theta is nothing but a what here, 1 over cot theta. In the same manner tan B is equal to 1 over cot B. So therefore, so here is what is the cot? Cot is nothing but 3 by 2. Substitute here the 1 over divided by 3 by 2. It will become a reciprocal of this. Tan B is equal to 2 by 3. I can able to say. Now let us pass on to the next part of this. Let us substitute all these things here. Okay. Now we have, let us find out what is a tan A. Tan is nothing but a what here? Sine theta divided by cos theta. What is sine? Sine we already identified as what here? 3 by 5. Where it is? Somewhere 3 by 5 here. Okay. So 3 by 5. Okay. Then what is the cos A? Cos A we have identified as what here? 4 by 5. I have to write here 3 by 5 and this one is what here? 4 by 5. On taking the reciprocal of this, tan A is equal to 3 by 4 you will get. Okay. Now we have this equation. You just see, this is the equation we have. Tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. This can be written as, okay, tan of A plus B. This is A. This one is considered as what here? B. We have this formula, tan A plus tan B divided by 1 minus tan A into tan B. Substitute for this. You already know what is tan A, tan B. So on substituting this one, tan A is nothing but a what here? 3 by 4. Tan B is nothing but 2 by 3. On substituting these values here, so final answer what will go on simplifying this thing, what you will get? 17 divided by what is that? 6. So these are all the problems regarding what here? So inverse trigonometrical functions. So thank you very much for watching the videos.